Well, hello, good evening everybody. Welcome back. Jiu-Jitsu 2000 here today. I'm back. I hope you're doing fantastic out there. In this video today, we have an offering from Siekon. This is a 100 amp lithium iron phosphate battery. So as you can see, it comes packaged very well in this nice box. And I gotta tell you, this box was actually inside of another box. So the packaging for the delivery of this battery was fantastic. So let's go ahead and get inside. We'll pull this thing straight out. And there's a look at our package. So the first thing that we see here in this package is these insulation caps, and look at this. They give us 4 M8 bolts, and these are the good ones that will allow you to use a Phillips head, so you don't have to have just a crescent wrench for these. You can use a drill, which I really like these kind of screws, and I thought that it was cool that they give us 2 extra, so very nice. The next thing that we see here is the user manual for this battery. So let's go ahead and take a look at this user manual. Right here you can see some contact information for Siekon. And then we're going to look right here. There's the table of contents of the user manual. Feel free to pause your screen at any time during this portion of the video if you want to read something a little bit longer. I'm going to go through fairly quickly. So here it talks about some safety stuff and then things that you can do before using the battery. And then on this page you can see that they have suggestions for long-term storage as far as temperature is concerned. -20 to 45 degrees Celsius, and then they say that you need to recharge a battery every 3 months. Now if you're going to operate the battery under normal conditions, you can go between -4 and 149 degrees Fahrenheit, but storage is from -4 up to 95 degrees Fahrenheit. This is for long-term storage. So make sure that you store it in a fireproof container away from children. It talks about keeping a long-lasting capacity, that you store the battery at least 50% charge. So very cool. And then on the next page there are the specifications of the battery. Everything you need to know about the battery, and I'll be talking about a lot of this stuff in the video today. And then of course on the following page you can see charge temperatures, discharge temperatures, storage temperatures, and then your self-discharge per month. So lots of different specifications, information here. I like the way they laid out this manual. They say that this battery is good for 5,000 cycles at 100% depth of discharge, which is fantastic. There's some more specifications of the battery. And then on the following page it talks about what to do before you use it for the first time. Test it with the multimeter, pull off the insulation caps, and put in the post screws. And then of course how to charge a battery and how to use it and stuff like that. Very interesting. And then how to test a battery with the multimeter. We'll be doing that here in a second. And then using your battery, it gives you a little brief rundown of the different types of connections that you can do. So right here, if you want to run 4 batteries in series or 4 batteries in parallel, it tells you what you'll get. So 4 in a series would give you 48 volts at 100 amp, and then 4 in parallel would give you 12 volts at 400 amps. And then of course it talks about wearing gloves when you're going to be connecting these batteries and dealing with wires and stuff like that. So very nice information that they give you here on this user manual. It gives you tons of information. So I like the way that this thing is laid out. It gives you lots of good information. When you're going to be wiring the batteries together, whether it's in series or in parallel, it's always a good idea to make sure that each individual battery is fully charged before making any connections. That way the charge balance on all of them is the same, or at least as close to being the same as possible. And then of course over here it talks about installation, how you would set it up in an off-grid system. Very neat. I'm going to scroll through this stuff fairly quickly because it doesn't really relate to us too much. There is some information on inverter settings, what parameters you need to put in for the battery. Very cool little picture of an inverter. We're almost done, folks, so hang with me. Recommended cable sizing chart right there, which is very cool. How to charge your batteries. Nice. And then the charging mode for lithium iron phosphate batteries. There's three different, so you got your T1, which is your constant current. T2 is constant voltage. Very interesting. So good information here. And then of course on this page it says the recommended power is 300 watts. If you're going to be using solar panels. And then here's some charge controller settings and parameters that they suggest for this battery. And then right here you see a troubleshooting chart with lots of information, what the problem is, what you can do to fix it. So good information there. And then on the last page we can see the warranty information right here for the battery. Right there is some more contact information for Siekon, as well as right here. And that's really all there is to the user manual. So the next thing that we see here is a little foam. That's to protect the battery for shipment. And then pulling it out of the bag, you can see that there's foam inserts around the bag. I like that they put it in the bag to keep the dust and water and stuff off of the battery. There is a silica gel pack in there that helps keep the thing dry. And so here we're taking a first look at the battery. So at this point I want to take the insulation caps off of the terminals. Let's go ahead and put some bolts on. Like I said earlier, I'm really happy that they include 4 bolts. These are nice bolts. So we'll go ahead and put these on. I love it when they have the ones with the Phillips. Just makes it so nice to put those on. Let's go ahead and take a voltage reading, see what the voltage is out of the box. So we are at 13.20 volts. So not too bad, but it does need a charge. So right here on the right you can see that we have a dedicated lithium iron phosphate battery charger. This puts out 14.6 volts at 20 amps. So we're going to go ahead and connect this to the battery and get our charging started. So we're basically going to wait until this LED right here turns green. Now while we're sitting here charging the battery, I thought that it would be a good idea to talk about some of the specifications of this battery. We'll start off with the current retail price at the time of me filming this video. You can pick this battery up. If you buy one of them, you can get them for 229 bucks. That's not bad, but if you get 4 batteries, the price goes down to $227 a piece. If you get 8 batteries, you can get them for $224.99 each. And if you get 16 batteries in one purchase, you can get them for $220.99 a piece. That is a fantastic deal for a deep cycle 1280 watt-hour lithium iron phosphate battery with 100 amps of capacity. That is just absolutely fantastic. Now if you think about lead acid batteries, you can get between 300 and 400 cycles generally out of a lead acid battery. But lithium iron phosphate batteries like this, which are built with grade A cells, these are EVE cells, you can get up to 5,000 cycles at 100% depth of discharge. That is crazy. These grade A EVE cells, these are in the top 10 of the lithium iron phosphate battery cell manufacturers. Now, this battery will retain 80% of its capacity even after your 5,000 cycles. Now, this battery is also much lighter than a lead acid battery. If you think about a 100 amp capacity lead acid battery, you're looking at something that's like 63 pounds. But a battery like this is 23.14 pounds. That is just crazy. And if you only go down to 60% depth of discharge, they say that you can get 18,000 cycles out of this battery. Now, compared to a lead acid battery, this battery here is 10% smaller. The cool thing about lithium iron phosphate batteries is there's no off-gassing. And if you puncture the side of a lead acid battery, you're probably going to see fire. But on lithium iron phosphate batteries, it's much more minimal in the potential to see fire if you puncture the side of one of these. Now, another cool thing about this battery is it does have an upgraded BMS. This is a JBD's BMS. Very, very cool. It has pulse equalization protection. It has overcurrent protection, low temperature protection, high temperature protection. It has overcharge protection, over discharge protection, as well as short circuit protection. There is a wide list of applications that you can use a battery like this for. So if you want to put it in your vehicle and maybe you're going to run a TV or something in the back of your van, or if you're in an RV, or maybe you're a van lifer, or maybe you're on a boat or a yacht or something like that. You can also use a battery like this for golf carts. You could put them on a boat and use them for trolling motors. They can be used for tool trailers. So maybe you're going around to the job site and you want to use it to charge power tool batteries or run tools or something that are electric tools. You could also use it for a backup power supply. You can use solar panels to charge a battery like this. So something like this would be ideal for off-grid situations. Now, if you do 4 batteries in parallel, you'll get 5.12 kilowatts per hour of storage. And if you do 4 batteries in a series, you get the same exact kilowatt hour of storage. But if you do the 4P4S, you can get 20.48 kilowatt hours of storage. 12.8 volts at 100 amp hour, that gives us 1280 watt hours of capacity. So if we were going to be running a small load of 50 watts, we could run that 50 watt load for like 25 hours. That would be the equivalent of maybe running a TV, a Roku, and maybe like a DVD player and charging your phone like all at the same time. If you want to bump that load up, let's say we're drawing 250 watts. On this battery, we could run that 250 watt load for about 5 hours. And if we're running a 300 watt load, that's about 4 hours of run time that we would get out of this battery. 800 watt load, we're looking at an hour and a half of run time. And then let's say we're running a 1200 watt load. We could do that for a little bit over an hour. So the performance capacity wise of a battery like this is just absolutely fantastic. This battery is IPX5 rated, so that is your dust and water protection rating. So this is, it's not going to be easy for dust to intrude this battery or even a light rain. So that is fantastic. Now this battery is made out of durable ABS plastic. Cool thing about the plastic that they use for this battery is it's flame retardant plastic. Now the low temperature cutoff for this battery is minus 15 degrees centigrade. That is 5 degrees Fahrenheit. When the low temperature recovery kicks in, that is when the temperature is above 3 degrees centigrade or 37.4 degrees Fahrenheit. Now they do say that they recommend when you're going to charge a battery like this that you use a 20 amp charger, and that's exactly what I'm using here today. It really is the sweet spot. However, you can go on a much higher charger input all the way up to 100 amps if you had to. but it's not really recommended. Now, let me be clear. This is not a starting battery. This is not something that you would put in your vehicle to try to crank over your vehicle. It's not designed for that. Some other cool things that you guys might like about these batteries is they will ship from a US warehouse. They do have a 24/7 online service, so if you need any kind of help, they do offer a 5-year warranty, and there's also a 30-day free return policy. Now, the wires that internally go from the BMS to the cells themselves, the cables for the positive terminal, they are using number 4 AWG cables, and then they're using 2 number 7 AWG cables for the negative terminal inside this battery. That is fantastic. That's going to be good thick wires that's going to reduce the amount of heat that can build up when the voltage is traveling through these wires. And as you can see, we have a green LED indicator right there, so it's telling us that charging is complete. I'll go ahead and disconnect these alligator clips. And let's get our voltmeter here, and let's take a voltage reading of this battery now that it's fully charged and see where it's at. 14.41 volts. That is absolutely fantastic, and as you can see, this battery is fully charged. I'm impressed with the voltage that I'm seeing here. So at this point, I'm going to go ahead and hook up a power inverter and start testing this battery. Now, there's lots of different options that you can use for power inverters. You could use something small like this little 500 watt pure sine wave inverter. This one works really good if you want to use this battery for a small system. Maybe you want to run a TV and a DVD player, or you want to run a desktop computer, a laptop, run lights. 500 watts, folks, is no joke. In fact, we use this off the grid to run a evaporative air cooler, and that cooler only pulls like 45 watts or something. So this inverter works very, very well. Don't sleep on these small inverters, but for today's testing, we're going to go a little bit larger. We're going to go ahead and run this Alpha 1500 watt pure sine wave inverter. So I'll go ahead and get this thing connected. So at this point, we're going to just kind of put this off and we'll turn this on. Okay, right now, if you look at these numbers right here, you can see the voltage of the battery. It's also telling us here we have 111 volts alternating current, and because we're not drawing any loads yet, it's not telling us what the alternating amperage is. So alternating current amperage, nothing yet, but it will change once we start drawing power. You can also see the green indicator down here telling us that it's ready to run. One of my favorite tests that I like to do is things that I can do out at camp. So let's go ahead and use this little hot plate here. We'll plug this in and we will turn it on to the highest setting. You can see the little red indicator lights up. I've got it on max. And we'll just set a small stainless steel pot on there with a little bit of water in there. Hopefully you can see that. We'll just set that there and we'll bring that water up to a boil. And if you look at the numbers, you can see that we are pulling 7.2 amps AC at 111 volts AC. So that's a pretty good draw for that battery. Now, another thing that we could use as a test is, let's say we're out and we want to charge power tool batteries. So let's go ahead and plug in this little DeWalt charger and we'll stick a battery in there, and you can see that we are now showing a flashing red indicator that we are charging that battery. So right now I'm guessing that we are pulling somewhere around 1,000 watts or more. As we look at that water heating up, you can see that it's starting to steam. And you'll also notice that the battery voltage will drop when we're pulling heavy loads, and that's normal. Once we stop loads, the battery voltage generally climbs back up. When that indicator goes solid, that battery is fully charged, and then I can run it in my drill. There's lots of applications that you can use a battery like this for. I'm going to fill these wires. They are warm to the touch, but they're not hot. We just heard the fan kick on the power inverter. That's a pretty heavy draw that we're drawing right now. That's only a 1500 watt inverter. Now that does not mean that the battery is limited to 1500 watts. It's not. The battery can perform with whatever inverter you want to use within the specifications of the battery. In the Chinook, for example, I have a 100 amp lithium iron phosphate battery in there currently, and I'm running a 3500 watt pure sine wave inverter. And I can run the air conditioning unit, I can run the refrigerator, I can run the microwave, I can run every light, the TV, internet using Starlink. I can run all of those things, charge power tool batteries, and all of that is off of a battery that's also 100 amp capacity. It's also a lithium iron phosphate battery. So in my testing right now, this battery is performing exceptionally well. So looking down there at the hot plate, you can see the red hot reflection off of the bottom of that. That thing is hot. So it's definitely doing a good job boiling that water. It is working absolutely fantastic. This battery is doing everything I'm throwing at it with flying colors. So now that my water has came up to a boil, I can go ahead and turn this off. And you'll notice, just like I said earlier, these numbers rise because now I'm not pulling so much current out of the battery. This battery is doing a good job. So while the hot plate is cooling down, let's go ahead and disconnect the hot plate. We'll set that off to the back and let that cool down. And let's just say we want to run a heater. This heater has two settings. It has a low setting and a high setting, and it also has a fans. If I go just to the first click, it's going to kick on a fan. So there you can feel a fan, and it's not registering anything on the display there because it's just a fan. But when I go to 1, that is the low heat setting, 1.8 amps, 1.9, 2.5 amps. And I'm feeling some heat already coming off of that. 3.3, 3.4, 3.8. That's a pretty good draw. 4.2 amps, 4.4. So that's pulling somewhere in the neighborhood of 600 watts, I'm guessing. Now if I go up to high, we'll pull that and see we're jumping up to 9 watts almost, or 9 amps, excuse me, 10 amps, 10.9, 11. So we're probably pulling somewhere in the neighborhood of 12 to 1300 watts. That's a lot of power. And as you can see, the battery is performing absolutely fantastic. This is a lot of heat coming out of this thing. And again, the cables, they don't feel hot. They're just warm. No problems there. And again, when I turn this heater off, you'll see the voltage drop. Let's turn it all the way off. There's the voltage back up to 13. Apparently this little power tool charger doesn't charge much, doesn't draw much at all. So we'll go ahead and disconnect the heater and see that it worked really good with that. And just for good measure, let's go ahead and bring out that Instant Pot. Plug this in, and this is going to be a pretty good draw as well. Pressure cookers are good because when you go camping, you can run a pressure cooker and cook your meals. So we're going to push that button and we'll just watch the numbers. Right now it's going to be heating, and we're going to see some pretty big numbers here in a second. As you can see, the battery has no problem running these tests. Charging a power tool battery, running a heater, running a hot plate, running an Instant Pot. It can run the cooler behind me, that evaporative cooler. It can even run the little window unit that I have, the lights that we're using to light up this room. It can run those. So a battery like this has lots of uses. Now I do want to stress that this is not a cranking battery. This is not something that you want to put in a vehicle and think that it's going to crank over that engine. That is not what these batteries are designed to do. So just out of curiosity, you guys might be wondering, with a 1,000 watt draw here and that battery being 1280 watt hours, that means that we could run this Instant Pot at 1,000 watts for 1.28 hours. But it's actually going to run more than that, because once the pressure cooker comes up to pressure, it doesn't draw that big 1,000 watt load anymore. Once it's up to pressure, everything drops. It doesn't even pull anything hardly at all once it comes up to pressure. And as you can see, the voltage rose up, the amperage went to 0, and our timer started. So that means our pressure cooker is now up to pressure, and it's not drawing anything from the battery anymore. The only thing drawing from the battery at this point is the little battery charger, which isn't taking much at all. In fact, it's not even registering on that little blue screen there. So the battery is performing well. I'll go ahead and end this test. It passed with flying colors. I like this battery. We can depressurize this pot now. Well folks, my final thoughts on this battery. This battery is absolutely fantastic. I was able to charge my power tool batteries. I'm able to run a hot plate. Maybe I want to scramble some eggs, saute some onions or mushrooms, or cook some sausage or whatever. Run a heater in my tent, run an Instant Pot. It performed extremely well with all the tests that I throw at it. It's charging my power tool battery as we speak. This is just a fantastic battery. I want to say thank you once again to Siekon for sending this battery out for review. I love it. It's working very good. If you guys are interested in this battery, I will put a link in the description box down below. With all that being said, folks, please feel free to leave comments down below, like this video, share this video, and until next time, I hope you guys have a beautiful day, and we'll see you on the next one. Bye for now, everybody.